we're now going to look at the very specific type of equation here. So equations in this form where you've got something sine x plus something cos x equals a constant number. Now, if that constant number is 0, it's not a problem because I could move the cos over, divide sine by cos and turn it into a tan function. But if that constant is any other number, I can't do that. There's two ways of doing it. The first way we're looking at it is what's called the auxiliary, or sometimes called the subsidiary angle method. And what we basically do is turn these two bits of trig into one trig function. And so I'm going to change it into a sine function. We remember when we expand sine, it goes the pattern, sine cos, cos sine. And I've got something cos, something sine. So it has that pattern. It just means that instead of sine theta, I've got a 3 there, and instead of cos theta, I've got a 4 there. So all right, that's fine. So the cos alpha, it's like the 4 is the cos alpha. Yes, I know it's impossible for cos alpha to equal 4. Let's forget that for now. So I put it on the adjacent side of my triangle over here. Now, when I look at the other one, and the sine alpha has been replaced with the 3. So on the opposite side, I'll write a 3. Work out the hypotenuse. It's our lovely 3, 4, 5 triangle. So I know that's 5. I don't normally write this down, but just to show you where I get my next line from. So I know 4 and 3 can't possibly be sine and cosine ratios. So I divide it by the hypotenuse. 4/5 and 3/5 can be ratios. But to balance it out, I've got to multiply the whole thing by 5. So what I now have in here is 5 times the sine of theta plus alpha. Because we've got sine, cos, cos, sine of those angles. And we know that's equal to 2. And so now it becomes a very simple trig equation to solve. The sine is 2/5. We do it just as normal. It's just that the angle we're working with now is theta plus alpha. I can work out alpha, because go back over here, I've chosen the tan ratio. I could have just as easily done the sine or the cosine, it doesn't matter. And so, all right, alpha is 36 degrees 52 in this problem. In the first two quadrants, sine is positive. So sine beta is 2/5. Normally I'd say sine alpha, but I've already used alpha, so I'll use a different pronumeral there. So I know that one is 23 degrees 35. That's the acute angle. Therefore, theta plus alpha, which we worked out was 36 degrees 52, is either 23.35, that's the first quadrant answer, or 156.25, the second quadrant answer. Now I just subtract the 36.52 and we get our answers. But I've got to check the original question. You'll notice one of my answers is negative 13 and 17 minutes. They want answers between 0 and 360. So all I do, any answer that hasn't fallen in that range, I just add or subtract, depending on what I've got to do, 360 degrees. So go around the circle again. If I add 360 to that, that becomes 346 degrees 43. And there's my two answers. Now, I could have just as easily turned it into a cosine function, because I could have created the pattern cos, cos, sine, sine. So that would have worked as well. Let's do it that one. So cos, cos, sine, sine. In this case, cos alpha is being represented with the 3, so I'll put the 3 on the adjacent side. Sine alpha has been represented with the 4, so 4 on the opposite side. The hypotenuse, once again, turns out to be 5. Now I have 5 times 3/5, which is a ratio, I can work with that. Cos theta plus 4/5 sine theta. It's 5 cos theta, but we've got to be careful. If it's not the sine, it's not the sine. Theta minus alpha is equal to 2. And let's work out alpha. Now, it'll be different to the last one, of course, because I've now got a different triangle. This time, that angle is 53 degrees 8. I'm in the first or the fourth quadrant this time. But the acute angle is 66.25. So I know that theta minus 53.8 is either 66.25, there's our first quadrant answer, or 293.35, there's our fourth quadrant answer. Add 53.8 to both of them, and this time both of the answers worked out. They're in between 0 and 360. So we have our answer. It's up to you, unless they tell you. Sometimes they tell you which one to change it into, but otherwise it's up to you whether you want to turn it into a sine function or whether you want to turn it into a cosine function. So we get this question then, how do I actually do it? Remember I said these lines I wouldn't normally write in. I'd look at this one and go, righto, what will I turn it into? I think I probably would have gone with sine. I tend to go with sine. In which case, the root 3 must be on the adjacent side because it'll be cos of the angle, and 1 will be on the other side. Bit of Pythagoras, the hypotenuse turns out to be 2. So alpha is pi on 6. We can work that out. Okay, see, I normally just go straight to that now, because the multiple of the trig function will always be the hypotenuse. So I know it's 2 times, I've turned it into a sine function, and the pattern is sine cos minus cos sine. If it's the sine, it's the sine. So I know it's x minus pi on 6. So sine of x minus pi on 6 is a half, first or second quadrant. So x minus pi on 6 is pi on 6 or 5 pi on 6. Add pi on 6 to both sides and we get our answers. Here's one from, 2003. Gosh, here's a while ago now. Here they forced our hands. They said, express cos x minus sine x. So it's not an equation at this stage, it's just this expression into our cos x plus alpha. So I'm going to turn it into a cosine function, but you'll notice the coefficient of both of them are 1. So both sides are 1. Hypotenuse becomes root 2. So this becomes root 2 cosine. If it's not the sine, it's not the sine. So it's going to be plus x plus the angle 45 degrees. Sometimes what they might do is, instead of getting you to solve an equation, they might get you to draw the graph, y equals cos x minus sine x. Which, you know, when you think about it, oh geez, 2 graphs, I'm subtracting them, but you turn it into one trig function, a lot easier to draw. 2010 HSC, express 2 cos theta plus 2 cos theta plus pi on 3 in the form r cos theta plus alpha. Oh, that's a little bit different. So, okay, what I did was I expanded out the cos theta plus pi on 3 just to see what's happening there. So I've got 2 cos theta plus 2 cos theta cos pi on 3 minus 2 sine theta sine pi on 3. But I can now group the cos thetas together. Cos pi on 3, of course, is a half. Sine pi on 3 is root 3 on 2. Now I've got it as 2 trig functions. I can bring it together into one trig function. And they've told me they want a cosine function for this one. So all right, cosine function goes cos, cos, sine, sine. So the adjacent side will be 3. The opposite side will be root 3. My hypotenuse then is root 12. Oh, that simplifies, doesn't it? 2 root 3? Yeah, 2 root 3. No. So we get 2 root 3 cos, if it's not the sine, it's not the sine, so it becomes plus pi on 6 for that one. So I personally prefer to do it that way. You'll see some books that got formulas for all this, to work out the coefficient, whatever it is, some formula. There's 11B. Okay.